Today, we're diving into a piece of technology you likely use multiple times a day without ever giving it a second thought. I mean, at first glance, it just looks like a completely basic, everyday plumbing fixture, right? But if you look a little closer, you'll realize it is actually a brilliant piece of engineering. Literally every single time you push that handle, it performs a hidden, highly coordinated magic trick right inside your home. Yep, we are talking about the mechanics of the modern flush.
Okay, let's dive right into this because this idea completely upends how most of us think about the modern bathroom. We kind of tend to assume that clearing waste out of our homes requires, heavy machinery, maybe motorized parts or complex electrical pumps constantly driving the water down. But that couldn't be further from the truth. The standard household toilet relies almost entirely on basic physics. Specifically, we're talking about the incredible forces of gravity and something known as the Siphon Effect. It's a completely passive mechanical system that works purely based on the laws of nature and some really clever design.
So, here's how we're going to break this chain reaction down today. First, a marvel of basic physics. Second, phase 1, the flush. Third, phase 2, the siphon effect, which is where the real physics magic happens. And finally, phase 3, the refill.
All right, let's kick things off with section 1, a marvel of basic physics. Let's look at the anatomy of a toilet.
To really wrap our heads around the mechanics here, it helps to divide the machine into two main arenas. Up top, we have the tank. Think of this as the control center. It sits up high, it stores the potential energy in the form of water, and it houses all those mechanical triggers. Then, sitting below that, we have the bowl. This is the action zone, the part that handles the actual waste removal. Separating these two in our minds makes it incredibly easy to see exactly how this whole sequence unfolds.
So, let's trigger the first major event. Section 2, Phase 1, the flush.
The very moment you push that lever down, you are instantly triggering a chain reaction that results in a massive, rapid transfer of water. It all happens in 3 rapid-fire steps. Step 1 is immediate, lifting the flapper. Pressing the flush button pulls a lift wire or a chain inside the tank. That chain pulls up a rubber seal resting at the very bottom of the tank, which is known as the flapper. Some models might use a central canister instead, but honestly, the result is exactly the same. You have suddenly opened the floodgates.
And that brings us to step 2, the tidal wave. You see, the flopper is brilliantly designed to float temporarily once it's lifted, keeping that bottom exit wide open until the tank is nearly empty. Because of that open hole, gravity instantly forces all of the stored water to rush down into the bowl below. And the speed? It's just astonishing. All of this happens in less than 3 seconds. That incredibly fast dump of a large volume of water is absolutely crucial. It's the key to making the whole system work.
And this brilliantly illustrates step 3, splitting the stream. As all that water crashes down from the tank into the bowl, it doesn't just splash around randomly. It is deliberately split into 2 specific directions at the exact same time. It perfectly divides its labor. A portion of the water flows through rim holes. These are spaced out along the top edge of the bowl to evenly wash down the sides of the porcelain. But the vast majority of that water is directed completely differently. It's forced straight down into a targeted opening right at the bottom of the bowl called the siphon jet. That powerful surge pushes us right into section 3, phase 2, the siphon effect. This is it. This is where the true physics magic happens.
But before we see the action, we kind of need to define the hardware. If you were to look directly behind the toilet bowl, you'd see a large, curved porcelain pipe. It's shaped sort of like an inverted S or a hairpin hook. This is called the trapway. Normally, when the toilet is just sitting there between uses, this trapway is only partially filled with water. And that partial fill is incredibly important. It creates a liquid seal that physically blocks smelly, potentially dangerous sewer gases from traveling up the pipe and into your home.
But during a flush, that static seal is disrupted in a rapidly escalating series of events. First, we have overwhelming the curve. Remember that massive tidal wave of water dumping in under 3 seconds? Well, it fills the bowl way faster than water can naturally flow out of that curved trapway. Next up, we create the siphon. Because the water level is surging so fast, it completely fills the upper loop of that curved trapway, totally pushing out all the trapped air that was just sitting inside the pipe.
Now, what's really fascinating here is the concept of cohesion. Once that pipe is completely filled with continuous water, 0 air bubbles interrupting it, a siphon is officially formed. Gravity begins pulling the water down the backside of the trapway pipe and into the main drain. But because of cohesion, which basically just means water molecules love to stick to themselves, the falling column of water acts exactly like a solid liquid rope. As gravity pulls the front of the rope down the drain, it drags the rest of the water, the waste, the debris, entirely out of the bowl behind it with this immense, vacuum-like suction.
So, the crucial takeaway is that this suction continues relentlessly until there is literally no water left to pull. When the bowl is sucked completely empty, there's suddenly no more water to block the trapway. Air abruptly rushes into the curve of the pipe, and boom, this entirely breaks the siphon vacuum. When that vacuum breaks, it causes that incredibly familiar gurgle sound you hear at the very end of a successful flush. That gurgle, that is just the sound of basic physics completing its job.
The bowl is empty, but the machine must automatically prepare for the next user, which brings us to Section 4, Phase 3, the refill. This reset happens in 4 highly dependable mechanical steps. Step 1 is sealing the bottom. Because the water has drained completely from the top tank, that rubber flapper we talked about earlier completely loses its buoyancy. It drops right back down over the flush valve hole, sealing it tightly with the weight of gravity so no more water can escape. Step 2 is opening the fill valve. Inside the tank, there's a floating mechanism. Sometimes it's a ball on a long rod, sometimes a cylinder on a vertical shaft. As the water level dropped, this float dropped right along with it. That downward movement mechanically pulls open the fill valve, allowing fresh water from your home's main water line to rush back in.
Let's move to Step 3 and see how this builds into an absolutely genius dual filling process. While the fill valve is busy pouring massive amounts of fresh water into the main tank to get it ready for the next flush, it is simultaneously doing a second job. It sends a very small stream of water down a flexible tube directed straight into the overflow pipe. This secondary bowl refill trickles down directly into the empty bottom of the toilet bowl. Why? Well, because it has to restore that critical water barrier in the trapway that blocks those awful sewer smells from sneaking into your bathroom.
Finally, we reach Step 4, shutting off. As the fresh water slowly rises inside the tank, that mechanical float rises right along with it. Once the water level hits the designated fill line, the float reaches a height that physically pinches the fill valve completely shut. The water flow stops instantly. The tank is full, the bowl has its water seal back, and the entire system just sits perfectly dormant, fully loaded with potential energy, waiting patiently until the next time the button is pushed.
And just like that, the cycle is complete. A perfectly choreographed sequence of mechanical levers, gravitational pulls, and liquid cohesion, all hidden behind a simple porcelain shell. It really makes you wonder, doesn't it? What other hidden mechanical marvels do you use every day without a second thought? The world is absolutely full of brilliant engineering hiding in plain sight, just waiting for us to take a closer look. Thank you so much for joining me on this explainer, and I encourage you to keep looking for the everyday magic all around you.